Hello colleagues, my name is Anton and I will lead today's webinar about usage of SmartPTT software for migration from one radio system technology to another. Here is a short description. What is SmartPTT software? SmartPTT is a highly customizable application and comes in several variants that provides different set of functionalities for different systems. Interface with radio system can be done via control stations or via IP connection to motor-turbo repeaters. Dispatcher software gives opportunity to control and log the flow of data and voice in radio network, request location of subscribers, and monitor the state of repeaters. Also, SmartPTT gives a set of software tools, such as web client and file transfer software, which increase radio network usability and functionality. SmartPTT has functionality that allows it to connect to PBX and give subscribers the ability to use PBX interconnection from radio network as well. The contents of today's webinar are listed here. We will have a short overview of analog systems supported by SmartPTT. Then we will proceed with a description of common migration plan. I will tell about what systems can be bridged within SmartPTT software and will describe a migration process giving examples. This webinar covers the typical functionality of SmartPTT application. Some of this specific functionality mentioned in the webinar could not be available in all regions. Please contact our sales team at sales@smartptt.com to identify functionality available for you. Any time frames mentioned are just best indication and could be changed without notice. SmartPTT supports following modes to work with analog signaling systems. Simple analog networks can be connected via control station. SmartPTT dispatcher can make all call into analog systems and listen for calls within analog system. Analog networks with MDC 1200 signaling can be handled by SmartPTT. It will require a motor-turbo control station with MDC signaling support. Motor-turbo contains a limited set of built-in MDC signaling features. Emergency signaling, to send up a help signal to a predefined person or group of people. The emergency feature also allows a user to sound an alarm of alert to alert the dispatcher in an emergency situation. The user is also able to acknowledge an emergency. Call alert. Call alert notifies the radio user of incoming calls if they are a short distance away from their radio. Call alert also informs unavailable users that someone is trying to reach them. And PTT ID, which identifies the user's outgoing calls on other users' radios. Select 5, so-called 5-tone signaling, is supported by SmartPTT also and requires a motor-turbo control station with Select 5 support as well. Supported options for Select 5 are a bit wider than MDC signaling. It includes radio block-unblock feature, radio check, and also selective calls, group calls, and private calls. When preparing a migration process, you will need to go over the following checklist. First, select a topology to migrate to. You will need to decide what is the topology which will give you the best available experience to price ratio. Next, estimate the loading on the radio network. Motorola System Planner gives an estimation graph, which allows to decide whether available system resources will be enough to serve predefined number of subscribers or not. Manage your fleet. Upon migration, you need to rearrange available fleet of radios into groups and slots to minimize loading per available group or slot and to keep user experience at good level. Migration to new networks can open up new possibilities, like trunked channels in LCP system instead of fixed slot picture in IP-side connect can resolve the issue with some slots being used more than the others. Then, upgrade the equipment. When upgrading from one motor-turbo topology to another, you can use same equipment to establish new network topology. Commonly, it requires license upgrade for your equipment. In case of Connect Plus system, it will require additional option board installation. Frequency licenses can also require an update. When going from analog network to digital, you will need to have a license to use digital transmission on a set of licenses you already own. Preparing a migration includes installation of new equipment, CPS programming, and organization of bridges between existing systems to allow users of different networks to talk freely to each other. So let's see what can SmartPTT do with different radio networks. Analog systems do not support conventional groups in motor-turbo sense, so it is only possible to bridge all voice from analog system as all call to group of any digital system, including complex topologies. For digital networks via control stations, it is possible to bridge groups from all digital systems and topologies. When bridging from control station, it is possible to have private calls bridged to IPsec Connect and full NAI systems. Classic IPsec Connect systems without NAI access can be bridged into any digital network in scope of group calls. Private calls can be bridged to IPsec Connect and NAI voice systems. Private calls will be accepted from any network except Analog and Connect Plus. IPsec Connect to IPsec Connect bridge will also allow you to transfer CSBK data between systems, which include remote monitor command, block and unblock radio, call alert, and radio check. Capacity Plus and Link Capacity Plus systems via control stations will accept only group routes. However, it is possible to bridge private calls from such hybrid systems to IPsec Connect or NAI voice. Capacity Plus and Link Capacity Plus systems via NAI voice have mostly same functionality as classic IPsec Connect, except that Connect Plus systems currently cannot be connected to NAI by any means, but this feature is under development and will be available later this year. Connect Plus systems can be bridged with control stations as gateways to analog or digital networks in scope of group calls. IPsec Connect system is also accepted on the same rules, group calls only. Common migration process in scope of technical work consists of listed here steps. I will give an example of migration from analog network to NAI Capacity Plus, describing each step. When we are going to migrate from analog network to mototurbo, it means we are going to replace our old subscriber units with modern ones which support digital radio transmission. At first, we will create an analog channel in newer radios for them to be fully complement with existing system. We can start replacement process partially, replacing some radios with newer ones. This will require us to create only analog channels to work on. Later, when we have repeaters already, we can establish a Capacity Plus site and start preparing new digital radios to switch to Capacity Plus network. So, now we are creating a set of channels to work with repeaters and a contact list for Capacity Plus system. Now we must create a bridge between these two systems, so that users will not notice the switchover process. Digital users will talk to analog users just the same way as they were talking before. That is the part where SmartPTT comes into play. We are installing a radio server in this system, connected to Capacity Plus network. Also, we have a gateway analog control station to transfer calls from one system to another. Within SmartPTT, we are creating a route which will connect all call of analog system, which is the source with ID 0, and group 1 of Capacity Plus system, which is a target with ID 1. This bridge will allow Capacity Plus users to talk to analog subscribers when talking to group 1 and vice versa. When we have all radios replaced and switched over to Capacity Plus system, we can detach gateway control station from radio server and work on Capacity Plus system only. Last correction will be to delete now obsolete analog channel from CPS of radios, and migration process is over. If you want to move your system from IPsec Connect to LCP NAI system, process will be just the same. First step will be to install new repeaters for LCP system. Second, create channels to be used in new LCP system. Third step is to install a radio server and bridge both systems together. In this case, we can use dynamic bridging option to create bridges for all private calls from one system to another and for all groups existing in the system. Final step is to move all repeaters over to new system, increasing capacity of trunk channels and disabling the routes to all system. Delete obsolete channels and you are done. Visit our website smartptt.com to find out more information about SmartPTT software. Follow us on Facebook and subscribe to our YouTube channel, user SmartPTT. If you have any questions, feel free to send email to us on info@smartptt.com or submit your request via submit form on support portal support.smartptt.com. Thank you for your attention.